Okay, so we're going to do all kinds of stuff with this function. And so we're going to find the asymptotes, intervals of increase and decrease, relative extrema, inflection points, and then we're going to sketch it. And so let's start off with the asymptotes. So if we're going to find the vertical asymptotes, remember for rational functions, you set the denominator equal to 0 and solve it. Well, this guy, it doesn't have any solution. So here for the vertical, we can just say, I mean, we could try to solve it, but obviously you can't have this guy equal 0 because this guy's always positive. So no vertical asymptotes. Horizontal asymptotes, though, remember that you have to find the limit as x goes to infinity, and also you need to find the limit as x goes to negative infinity, because a lot of times they go to different spots. So, and especially if you have roots, you have to be even more careful. Okay, so let's do this one. So let's do the infinity one first. So we use our usual, so you get infinity over infinity if you plug it in. So our usual trick of dividing by x to the highest power, and you guys might have forgotten by now, but so this guy, you divide by x. So this one, the top part is easy, you know, you just get, this is just 1. But on the bottom here, you have to get the x inside of the square root. And so then you have to say, okay, well, what does x equal to inside of the square root? Well, it equals to x squared. Now here, this is where it gets tricky, because this is for this one, but for this guy, when I do the same thing, I have to be much more careful, because you'll notice that when x is going to negative infinity, this guy, x, is always going to be negative. So this guy's going to be negative. But this guy's always positive, so the only way you can make them equal is by making this guy negative square root of x squared. So that's why in this one, although for this guy, you can just bring it inside of the square root, no problem. So let me write this out. This is x squared plus 1 over x squared, and then over x squared. In this one, when you do the same thing, you're going to divide by x on top, but then to bring it inside, it's not square root of x squared, it's negative square root of x squared. So this negative comes from this guy. Okay. So anyways, so if you do the rest, so this guy equals to 1, and then this guy goes to 0. So this guy is equal to positive 1. And then here on this guy goes to 1. This guy goes to 1, this guy goes to 0, and so this guy, because of this negative now, is going to be negative 1. So this guy has 2 horizontal asymptotes. Now, when x is going to, so let's do this. So over here, alright, so what we have so far is horizontal asymptote at +1 and horizontal asymptote at -1. So when x is going to negative infinity, it's going to be going down here, and then when x is going to positive infinity, it's going to be going up here. Okay, so that's that guy. Now let's do all the other stuff. So we need to find the derivative. And so we have to do the the quotient rule. So the derivative of the top is 1 times the bottom, square root of x squared plus 1, minus the top times the derivative of the bottom, which is going to be 1 over 2 square root of x squared plus 1, times the derivative of the inside, which is just going to be 2x. And so these guys are going to cancel. And so what we get is that, oh, and all this is over the denominator squared, so x squared plus 1. Okay, so then we've got square root of x squared plus 1 minus x squared over the square root of x squared plus 1. Okay, so then we multiply, forgot. And then all this is over x squared plus 1. Okay, so then we multiply this guy, top and bottom, by square root of x squared plus 1, square root of x squared plus 1. And so then what we get for the derivative is x squared plus 1 minus x squared over, and then here I'm going to write, instead of x squared plus 1, I'm just going to write it as x squared plus 1 to the 1/2. And then if you do the tortilla, this guy ends up down here, so this is times x squared plus 1, and I'm just going to write this to the 1 because I'm going to combine it in a little bit. Okay, so then in the end you get that the derivative is 1 over x squared plus 1 to the 3/2. And although that took a while, you'll notice that there are no critical points. Okay, so since there are no critical points, you still need to do the number line. The only thing that's going to happen is that there's no change in direction. So either it's always increasing or it's always decreasing. So here, for example, if you plug in 0, you'll notice that you get positive, which means that this guy is going to be always increasing. Okay, so that's fine. No problem. Okay, so then let's get the second derivative. Let's do that in pink. Now this one is a little bit easier. If you bring this guy up as x squared plus 1 to the negative 3/2, then you're going to get negative 3 over 2, and then x squared plus 1 to the negative 5/2. So if you bring it to the bottom, it would be positive 5/2 at the bottom. Okay, and then times the derivative of the inside, which would be 2x. Okay, so then what we end up with Da-dun, da-dun. What we end up with, sorry, just wanted to check something, is, so these guys cancel. Okay, so then you get the pips, and you'll notice that you have a pip for the numerator when x is equal to 0. So again, the denominator can't equal 0, but the numerator can. So we have our pip at 0. So let's do our number line. So here's our pip. And so let's plug in test points on the left and the right into the second derivative. And if you plug in -1, you'll notice that this guy is going to be positive. If you plug in +1, you'll notice it's negative. So you've got positive, which means concave up, and then you've got negative, which means concave down. So what this tells us is that we have a inflection point at the point 0, and then if you plug 0 into the original, you'll notice that you get 0 for the y value. Oh, inflection. Alright, so this pretty much gives us what we want. We have an inflection point here, no maximums or minimums. And what color do you guys want to graph it in? How about a nice little grayish color? So I know I have a horizontal asymptote. So as x goes to -infinity, it goes to -1, and it's always increasing, and concave up, and then right here it goes from concave up to concave down, and then it goes to +1. And so that's it.